Good day, grade 12s. In this video, we're going to be taking a look at some more calculus, specifically the cubic function, and then how to use the derivative to find certain information about the cubic function. Now, specifically, we will be taking a look at um, differential calculus, of course, which is about 35 out of the 150 marks for your prelims and your finals. Now, the question in this case I'm going through is the June 2022 exam paper. And now in this question, they start off by telling you, okay, a sketch below represents the function f of x equals to x cubed plus bx squared plus cx plus d, and g of x equals to ax plus q. The points A, B, and C are 2 points where the graph intersect, and B has the coordinate of 2 minus 16. They also tell you that C is 6, 0 and is an x-intercept of f, while L and M are the turning points of f. Now, the first question they ask you then is to show that B is minus 5, C is equal to minus 8, and D is equal to 12. If it is given that the first derivative is equal to 3x squared minus 10x minus 8. Now, in this case, there's a few ways we can approach this question, but the simplest and easiest way in this case would to start off by deriving this f of x that they gave us. So in other words, by first deriving f of x equals to x cubed plus bx squared plus cx plus d, and then comparing it to the derivative that they gave us. So what I mean, for instance, if we take the derivative of f of x in this form, then we know that the 3 comes down and multiplies with the 1 in front, and we subtract 1. So it's 3 times 1, it gives me 3, and then I subtract 1 from the exponent, so it gives me 3x squared. Then if I differentiate the next term, that would give me 2bx, and then finally the cx would just give me plus c, and the derivative of a constant, which in this case would be d, because there's no x attached, would just be 0. Now if we compare that to the derivative that they gave us, which was 3x squared minus 10x minus 8, we can see that the a values align, which is the values in front of the x squares. Then this 2b and the minus 10 should be equal because they're both in front of the x's, and then this c and the minus 8 should be equal because they're both without an x. So from there we can then say, okay, we can find b by saying 2b is equal to minus 10. So we divide on both sides with 2, and we get that b is just minus 5. And then for c, we can show, okay, but this is just going to be equal to minus 8. So far we have proven that b is minus 5 and then c is minus 8. Now we're kind of left in a situation here where we can't find d the same way, but they did give us another point on the function. So to find d, we can then just use the b and c values that we calculated, the a value that we have, which is 1 in this case, and then the point b to help us find d. So we do that by substituting in a, the coordinate b, 2 minus 16, b equals minus 5, and c equals minus 8 into this equation. So into f of x, which is equal to x cubed plus bx squared plus cx plus d. So then f of x, which is just y, would be minus 16 equals to x is 2, so 2 cubed plus, well, b in this case would be minus 5 times 2 squared plus well, C is minus 8, so minus 8 times 2 plus D. So from there we can then kind of solve there. So we have minus 16 equals to 8 minus 20 minus 16 plus D. We solve for D, throwing everything over to the other side, so it's minus 16 minus 8 plus 20 plus 16, and that would then just give me that D is equal to 12. So there we've just proven that B, C, and D are the values that they gave to us. So our approach was first use the two different first derivatives to compare to find B and C, and then substitute that B and C value along with another point on the function into the formula. Now the next question then in this case asked us to determine the equation of G. Now if we take a look at G, it's a straight line. So that means it should have the form y equals to mx plus c. So when we want to find the equation of the straight line, we normally start by trying to find the gradient first, and then we see if there's maybe a point we can substitute in to help us find c. So in this case, we can find the gradient by using point B, which is 2 minus 16, and C, which is 6, 0. coordinates of C was given to us and B was also given to us, and they're both on the straight line. We can use this to find the gradient, and the gradient formula is equal to m is equal to y2 minus y1 over x2 minus x1, and then we get that 0 plus 16 over 6 minus 2 would equal to 4. So then I can substitute that gradient into my straight line equation. Thus y is equal to 4x plus c. And now I find another one of my 2 points, which can be B or C, and I substituted it in to this equation that we have so far. Thus B2 minus 16 into y equals 4x plus c, which would then make my y value 16, my x value 2 plus c. Then it would give me that minus 16 equals to 8 plus c. Therefore, c will just be equal to minus 24. Therefore, the equation of the straight line would just be y equals to 4x minus 24. Okay. Then question 8.4 gives me, if it is further given that the coordinates of point A are x minus 30 or x minus 36, determine the length of AM. Now, in this case, it is important to note that M has a y coordinate of minus 36, and A also has a y coordinate of minus 36. That means both of these coordinates are on the same horizontal line, like I'm indicating with the dotted lines. Therefore, we just need to take the two x values and subtract them from each other to find the distance. So therefore, we need to find the x value of A first. And now A is a point on the cubic function and on the straight line. But and we also know the y value, so we can take one of those equations, substitute in the y value, find the x value. But I'm going to use the straight line in this case because it's just going to be simpler. So 4x minus 24 with y being equals to minus 36. That's minus 36 equals to 4x minus 24. So we have that minus 12 equals to 4x, and then x is therefore equal to minus 3. And like I said, because A and M are on the same horizontal line, because they share the same y coordinates, we can therefore say the length of AM is simply just the 2x coordinates subtracted from each other. So it's going to be 4 minus 3, which is then just equal to 7 units. Okay, almost done. Now, A flower doesn't dream of the bee, it blossoms and the bee comes. So we shouldn't wait for things to come to our side. We have to work for it and grasp it as when we have the opportunity.